Example 8.14. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion? So we want a sample size about the population proportion. Now the usual formula that you're gonna get in the textbook, okay, so the sample size will equal, textbook write down as z squared times p prime times q prime over e b p squared. So what it is you need to find a z score. You need to know the sample proportion p prime and the error tolerance that you're willing to take. Now q or q prime is always 1 minus p or p prime. So this p and q should add up to 1. Okay, so this is a general formula. In our problem, what do we know? So given in the problem, we want a 90% confidence level. Okay, 90% confidence. And we want to be within 3 percentage point. So what is 3 percentage point? Okay, and the keyword within is telling us the error or EBP, okay, they're the same thing, is what is 3%? 0.03, okay? So those are the only thing we're given. We do not know P prime. When we do not know P prime, we make it fair, right? We say, okay, it's a 50-50 chance. So in that case, when P prime is unknown, we meet in the middle. We use P prime equals 0.5. Okay, we use 50%. So that's the key to this example. So to solve the problem, you use the formula n equal, okay, what is a z-score associated to 90% confidence level? Now you know 95% correspond to a z-score of 1.96. But right now we want a 90%, not 95. So the z-score should be, and in the textbook, is 1.645. So use that number, and they are always associated and for the same z-score. Okay, so it's 1.645 because we want a 90% confidence interval. Okay, for the p-value, okay, p prime, because we do not know, we plug in 0.5. And if we know it, if it's, let's say 0.8, then we plug in 0.8. Now q is 1 minus p, right? So 1 minus 0.5 is 0.5. You just need to make sure these two numbers add up to 1. Okay, so then you divide it by, you have to square the z-score. And then you divide it by the error, okay? E is 0.03 squared. Now this is what you use, okay? And it's the same as the formula that I give you in the handout. The formula in the handout is says 1/4 times the z-score divided by the error quantity square. Why do I prefer that formula better? It's equivalent, okay? Because 0.5 times 0.5 is 1/2 times 1/2. It's the same as 1/4. Why I prefer this formula is because sometimes a lot of students forgot the square here or the square there. So if I write it this way, z over e, and then you square it, you only square once, you have less chance of forgetting that square. And you will get the same answer, just 1/4 times 1.645 divided by 0.03, and then you square it. Either equation will give you the same answer, but I prefer this better because you have less chance to make a mistake. But again, it's to your preference, okay? So the n using this formula, from your calculator, you get approximately 751.7. Again, we don't just round it, we have to round up. So it doesn't matter what this number is. All we need to know is we need one extra person, so it's 752. Okay, we need to survey a whole person. So we need to survey 752 cell phone customer aged 50 plus in order to be 90% confident that the estimate sample proportion is within 3 percentage points of the true population proportion.